Hey guys, welcome to our first official video for AP Stats. And this is obviously the first of many lectures that you guys are going to be watching with me here. And all of our notes are going to be via these videos. So as we're going through these, you guys should have a copy of the slides, like a paper copy, that you can fill out on your own as you go through them with me. Keep all your notes in a binder because you'll want to reference these later on when you're studying for quizzes or doing your homework or whatever else. Because this is the first video, I have a few things I want to talk about before we get going. First of all, you'll notice on each section that we're doing right here, we start the year actually in chapter 4, and then we go back and do chapter 1 and go in order from there. But you'll see there's a section number 4.1 part A, 4.1 part B, etc. Generally, there are no more than 3 parts in almost all of our sections here, so you may have an A, B, C, or just an A and B, and it just kind of depends section to section. I like frequent quizzes in AP Stats, so there's usually a quiz every 3 lessons or so, like per section. Most sections have their own individual quiz. At the bottom right here, you'll see page numbers written down. Those page numbers correspond to the pages in the textbook that you can read to kind of get the same content that was covered in the video. And I really recommend you do get used to kind of reading through our textbook. It's written really well. It's easy to kind of follow, and it gives even more detail than what you're getting here in the videos. So, typical class for AP Stats is going to involve 1 or 2 videos. So we may do 1 section, we may do 2 sets of videos for a section, depending on how much content is in those. This lesson, for example, is a 1 of 2-parter, so you'll also watch the second video to go along with this first lesson. And what we're going to talk about here is the idea of sampling and surveys to start out our class. This first unit is very heavy on like just thinking and writing, and it's not what you're used to seeing from a typical math class. So let's go ahead and jump in. So what you guys are seeing right here on this slide is a part of one of many what are called Federalist Papers. These are a bunch of essays written in like the late 1700s by our founding fathers, people like Alexander Hamilton, Thomas Jefferson, James Madison, stuff like that, talking about how great freedom is and how we should be our own country and kind of all that brainstorming that went in before the American Revolution. A lot of those essays, it's known who wrote them. But some of the essays, like the author's name, has been lost to time. This is one such essay, and there's a bunch of essays here, but this is one who the author wasn't already known. What I want you guys to do before I talk more is circle 5 words in this document. So select 5 words. Just pick them right now without thinking about it too hard. Choose your 5 words before we progress with this activity. Okay, so I'm assuming by now you've selected your words, circling them on your paper, or if you don't have a paper, highlight them on your slides or whatever, but you should have your 5 words identified. There are lots of ways that you can find the author of an unknown document using it like word choice and stuff like that, but it turns out that average word length is actually a good indication or a good tool you can use when you're trying to figure out if somebody wrote something or not. So, like some people just tend to use bigger words when they write, and that's true between different documents that they've written. Some people like to use shorter words. So if you know the average word length of a document, in theory, you could look at that, the average word length. So if I know James Madison is average is this many like letters per word, and then I look at this document, I could see if perhaps he was the one that wrote this document. So we could sit here and we could count every single one of these words, and we could average all of those and get an answer for this document here, but that would take forever. Actually, with technology, my computer could probably do it in a few seconds. But for the sake of argument, say we couldn't just have our computer tell us what the average was. Going to all of these data points right here and then averaging all those numbers, gonna be terrible. So what we're gonna do instead is take a sample. A sample is a smaller group that we're actually going to collect data from because our population is too big and time consuming to talk to every single person or to get every single word accounted for. So this is vocabulary you've seen before. You would have seen it with me a little bit in Algebra 2 when we did those stats lessons. But I have a few definitions written up here. And when I post definitions like this, I'm making this video at the end of the summer. I did, like, throughout this whole summer, I've been recording videos. Later on, I realized I can actually pause the video and like put stuff up there. At the beginning of the year, I didn't know I could do that. So you'll see definitions up here already for now, but later I'll stop doing that. Please make sure that you're not just like blindly writing down what's on the slide, not listening to me when the definitions pop up there, but that you actually take the time, pause the video, and listen and give these your full attention. The population is the whole group that you care about. It is whatever is under study, and that is up to you as the researcher what your population is. Maybe I care about the entire United States. Maybe I only care about adults over the age of 50. Maybe I only care about teenagers. Maybe I only care about St. Louis. You're allowed to establish your population, but it's everybody that you want to know about. In our problem, the population is all 130 or however many words there are in this document. The population is everybody. A census, you've heard of the US government census. There's one going on right now in 2020, done every 10 years, where the government goes and collects data from every single person out there. A census is really time consuming to do. It's a really big deal and it costs a lot of money. So you could go to every single person, but for a lot of things, it's not always realistic to be able to get data from everybody. So instead, what we do is we collect a sample, which is like a subgroup of your population. And if you do a good job with your sample, that sample data should do a pretty good job of representing the whole population. That's the goal. But there are a lot of things you can do in statistics where your sample doesn't actually match up with the whole population. And our little example here with the words is actually a good representation of what can go wrong. So this is a lot better when I can actually get a whole class worth of data to show you guys, but I want to show you what's happened. This is data that I've had over the years just from different people's results right here. So what we do is we take those 5 words. You guys selected 5 words earlier. Count up the number of letters in each of your 5 words. So if my first word is resorts, resort is 6 letters long. So I would take 6 letters plus however many else. In your 5 words, count the total number of letters. And then once you have your total number of letters, divide by 5 to get an average. So add up your 5 letter lengths, get a total number of letters, divide it by 5. This first picture right here shows over the years what happens, what kind of results people get. People have gotten as low as 2. I had a kid who picked like of, at, and like little tiny words like that for their sample. And people have gotten as high as like 10 letters. When they do that, they pick giant words like constitution, maintaining, and stuff like that. The actual average, if you take all 130 of those words and you average them, the number of letters, the actual average in this document is a 4.9. So 4.9 is the true average, which is like right here on my dot plots. Most people tend to overshoot that average. Look at all these people who go too high. There's a lot of reasons for that. Probably the biggest, easiest one to see is the bigger words just grab your attention more. Your eye drifts to those bigger words because they take up more space on the paper. But almost always when we do this, people's results are too high. And I'm guessing many of you who are watching this video, your answer is probably somewhere in this circled range right here. This is not a good situation when you have something like this going on. This is called a biased sample. Bias means that you are unfairly favoring one side of the answer, okay? People use the word bias wrong all the time in AP Stats. It's a word that people they use bias to mean did a bad job. It's not only that we did a bad job and we didn't actually estimate what we were supposed to, but it's that we're consistently favoring one side over the other. Not every single person overshoots it, but most people do. And if I use this strategy where I just choose my own 5 words, more often than not, I will overshoot the actual answer. Okay? So what we're doing next, to make it more fair so our sample isn't biased, we are going to go ahead and actually choose our 5 words randomly. So this table right here puts a number to every single word in that document. And this time, instead of making our sample just whatever 5 words we feel like, we're going to use our calculator to randomly select our 5 words. So, do button on your calculator here if you have one. And if you don't, you can just Google random number generator and you'll find something. First thing I need you guys to do, and this is like a one-time fix, you don't need to remember this. Type in a bunch of random numbers. Just type in like a string of whatever, mash buttons basically. Hit this arrow right here that says stow. And then what I'm going to do is I'm going to go math, PRB, rands. Okay? You just do that one time. Mash buttons, store, random. What this does is it basically seeds your calculator, so it starts from a random place. It's not important what it does, but just make sure you do this, because when our calculators all start, they're on the same factory setting, and it's possible that you would get the same random numbers as me, which is not what we want to do. So you never need to remember that again. Just make sure you've done it. What I'm going to do now is hit PRB, math, probability, and I'm going to choose random integer, randint. When you choose randint, your calculator, if it's newer than mine, might like actually give you like a little menu to prompt, which is great. What I'm going to do, because my calculator is a little older and didn't do that, I'm going to put 1, comma, and there are 130 words. So this is going to randomly choose for me a number between 1 and 130. And if I do that, my first number was 66. So 66 was going to be the word parts. That's my first word for my sample. Okay, and that obviously has 5 letters in it. I would do randint again, and I would do it 5 times total and choose my random words that way. If you get the same word, just redo it. But do randint 1, 130 5 times and get your 5 words. And then calculate your average again. When you do that, you should find that, well, you just have 1 sample right there. So your 1 sample still could be something low or high. So I'm not promising you got the actual answer of 4.9. But what you'll see, here's 4.9 now compared to 4.9 before. So we don't magically get the right answer always when we do a random sample, but we're not biased. We've got about as many below the actual answer over here is about as many above. So this isn't biased, which is good because we're not favoring one side over the other. So the moral of the story with this little activity here, human beings cannot be random. You can't be like, oh, I'm going to randomly pick my sample. You need to use some sort of random process. Otherwise, your data can and will be biased. All right, so let's go ahead and learn a little more vocabulary here. This first thing is something I already mentioned, but bias in general in statistics means that you are consistently over or underestimating the actual value you're looking for. There needs to be like a systematic favoring or unfairness to what you're doing, where one side is getting chosen over the other more frequently. There are a couple different ways that you can sample where if you don't think about it too hard, it might seem okay, but it actually will lead to biased results. 2 examples of that are written right here. We have something called a convenience sample, and we have something called a voluntary response sample. Both of these are bad sampling techniques that you should not do. Okay. In general, with AP Stats, this isn't really a buzzword class where you have to memorize that's a convenience sample, that's voluntary response. If you don't know or remember the name, if you can at least describe it and identify why it's a problem, you're totally fine. So don't worry and get too hung up on like, oh, I have to memorize and identify this specific vocab term. A convenience sample is choosing people who are easy to reach. So if I wanted to know what St. Louis feels about some issue, I could walk to the Galleria and I could go there and get my data from people currently at the Galleria. Obviously, people who are at the Galleria at this moment in time are not representative of the whole population. For example, I'm recording this video 10 a.m. on a Wednesday. People at the Galleria now would not be people who are like full-time employees, presumably. So they may feel differently on certain issues than other people. Another bad thing I can do is use what's called a voluntary response sample, which is basically where you allow people to join a general invitation. So they choose themselves for the sample. Example of this. Let's say I wanted to figure out what people thought about some issue, and I send out a survey to everybody. I've used this example in class. We've talked about mailing things back or something like that. But generally, when you allow people to, hey, respond if you feel like it, you're going to hear from people who feel strongly about the issue. People who don't care as much aren't going to bother to respond. If I want to know if we should fire this coach or something like that on this sports team, and I put up like a little survey on the top of my ESPN website, people who don't care aren't going to respond as much. You're going to hear a lot more from people with strong emotions on both sides of the issue. When I give a survey to my students about whatever, so like I ask about like what you think about the class, et cetera, end of year surveys, kids who really aren't stereotypically super motivated, don't check their email so much, probably won't even bother to respond, where the people who do are the ones who I'm more likely to hear from. So anytime you take a survey where you're relying on people to get back to you, you have to take it with a grain of salt that certain sorts of people may not be represented in your results. All right, this slide right here is a really important one. When I get kids fresh in AP Stats, I find that conceptually, they understand what's going on. They do a really good job, and you guys in general, by making it to this class, are generally pretty perceptive kids. But even though you may understand what's going on, I see this in the summer work a lot, the wording that you put on your papers doesn't really, it's not like fully synced up with what you have going on in your head. In other words, your wording on the paper doesn't reflect what you actually understand. So you need to be very careful with your wording in general and AP Stats and make sure that you're actually like saying what you mean to say. When I ask you to identify why a certain like procedure is biased, you have to do two things. And there will be a question about this on your first quiz. You have to explain what's the problem with the design that they describe. And you have to explain how that problem would lead you to over or underestimate whatever it is you're trying to estimate. So let's practice that with a little example right here. I want to know how much time students are spending on their homework per night on average. So I want to know the average amount of homework time spent. And I decide that for my sample, I'm going to walk into the school library right after school, and I'm going to talk to those kids and figure out like how much time they're spending on average. Why would this sampling procedure be biased? Maybe pause me and think about that. Give yourself a little bit of think time here. But the idea that I'm looking for is kids who are in the library after school probably are more motivated students in general. They probably spend more time on their homework because they're actually right after school doing homework in the library. Kids who aren't so motivated are going straight home, not thinking about it, and just doing their thing. Okay? So if I only sample from the library, I'm probably going to get kids who are more likely to do lots of homework. So my estimate that I get for how much homework kids do is probably going to overestimate the real answer. My answer will probably be higher than the truth because kids in the library are more motivated. So I'm going to go ahead and throw up like a nice little written up explanation of what I just said. All right, so you'll see a nice written up explanation there that would get full credit on a quiz or test. I identified a problem with the design, and then I talked about whether that problem would make me over or underestimate the true answer. Now, in AP Stats, they don't actually care so much about which side you take. They just want you to pick a side. So let's say you looked at this same problem and you were like, I bet kids in the library after school are there socially. And kids in the library after school aren't doing anything when they get home anyway. They just want to hang out. So I think kids in the library will do less homework than average. Not as strong of an argument, like I think my way makes more sense. But if you argue that way and you do those two things, you'll get full credit. So they're not saying like, do you like know the truth about the situation? If you make a good argument for the other side, AP Stats in general is very forgiving about that. And they're totally cool with it as long as you fully explain your answer. So let's wrap up this lesson by talking about two more examples right here. I want to just briefly discuss these and then I'll throw up the answers so you guys can see what would get full credit. First of all, in terms of vocabulary, let's identify what each of these is. So Dr. Grauer wants to know what proportion of families oppose budget cuts to the athletic department. Who thinks we should cut our athletic budget? And then he walks into the gym, basketball game going on, and he ends up asking those people what they think. Okay, that is a convenience sample. First off, he's using data that's just easy to get to and right there at hand. But people who are in the gym for a basketball game probably really support athletics in general and care about athletics. People who don't care about athletics are probably at home, not even available to be chosen for the sample. So what would this do? This would actually lead us to underestimate the people who want budget cuts, the people who oppose budget cuts. Oppose budget cuts. We would overestimate the percent who oppose budget cuts. We would be underestimating the proportion who are in favor. So it's all about what they're asking for. Last one right here. A survey is sent out by mail to MRH residents about whether we should start a Pokemon club here at MRH High School. This is something where if you got this and you're like, what? Pokemon Club? I don't care. Then you're not going to bother responding in the first place. This is a voluntary response sample. And what you would find here is the people who are super passionate, yes, we should do this, are going to respond. People who don't care, probably not so much. So we would expect that our results would overestimate the true support for this club. All right, so I've got little model solutions written right there talking about what we just discussed. Like I said, this is something that kids usually, like their wording isn't as clear as it needs to be. And it's something that will cost you points on like quizzes and stuff like that if you don't do those two things that we talked about. Abbreviations, spelling, stuff like that, not as important, but saying what you need to say really is. So that is the end of our first lesson on sampling, and we'll talk more about this in 4.1b.